All right, 8th grade, this is video 2 of lesson 8.6. We're going to pick up with guided practice 2. Here we have a problem where, unlike video 1, we can't simply rewrite this as a proportion. We have 3 fractions, all with different types of denominators. So instead, we're going to approach this a lot like the beginning of the chapter, where we want to first start by factoring. All that we have to factor here is our denominator of our third fraction, and that's a difference of 2 squares, so z plus 1, z minus 1. Now, in order to add or subtract, we have to have common denominators. So our approach that we're going to take is to actually clear fractions rather than rewrite everything to have the same fractions. So to clear fractions, just like we've done in many other chapters, we want to multiply every fraction by the least common denominator. It's just going to look different in this chapter. This is the new piece. So our least common denominator, if we look at the 3, we have a z plus 1, a z minus 1, and then this one has one of each. That means our least common denominator is actually going to be one of each of them. So a z plus 1 and a z minus 1. So we're going to multiply every fraction by the least common denominator. So we're going to take 2 over z plus 1 and multiply it, ignore the highlights for now, by z plus 1, z minus 1. Then we're going to take this fraction, 1 over z minus 1, 1 over z minus 1, and multiply it by our least common denominator. And then same with our last fraction on the other side of the equal sign here, negative 2 over the denominator, and we're going to multiply that by our least common denominator, z plus 1, z minus 1. So if we're ignoring the pink, we rewrote every fraction, but we included a z plus 1, z minus 1 in every numerator. This is slightly different from the adding and subtracting lesson of 8.2, because we're not rewriting them all to have the same denominator. We're multiplying everything by the same value. So for example, if we have something like 2x minus 7 equals 5, we could multiply everything by 2. It would be very silly in this scenario, and get 4x minus 14 equals 10. We've not changed our equation other than just how it looks. We basically unsimplified it, which is what we're doing in this lesson, but with more complex values than just 2. Okay, so we're multiplying every term. So it's that same idea as what you do to one term, you have to do to all the terms. Both sides of the equation, keep it balanced. Okay, so now for the pink. What I did in the pink is I used the highlighter to just cross out everything that each fraction has in common in the numerator and the denominator. So these both have a z plus 1, these both have a z minus 1, and these both have both. And all that's left, 2 times z minus 1 times z plus 1, and a negative 2. So we just cleared our fractions. Now we simplify. Distribute our 2, 2z minus 2. Distribute our negative 1 minus z minus 1 equals negative 2, and we solve. Combine like terms. Add 3 to the other side. We get the value z equals 1. So that's the process that you're going to use to solve these. Factor what you can. Find the least common denominator. Multiply every term by the least common denominator, which would only happen up in the numerator here. Clear what they have in common. Simplify and solve. Now we had a note up here, and I mentioned this in video 1, you need to watch out for extraneous solutions. Rational functions have restrictions. We cannot divide by 0 in the denominator. That means when we did this factored step here, 1 and negative 1 both would give me 0 in the denominator. Well, this question gave us an answer of z being 1. Well, if 1 cannot be a denominator, a variable value for our denominator, it must be an extraneous solution. Okay, so that was 2b if you're following along in your book. We're going to do 2c next, which is going to work the same way, but we're not going to deal with extraneous solutions in this one, so we'll take a little step back. Okay, give me just a moment. Augie's playing with my cord. Let go, buddy. Thank you. Okay, so in 2c, we have 3 fractions, none of which have anything in common as far as being able to rewrite this as a proportion. Okay, so instead we're going to factor what we can, and all we can factor in each of these is just a greatest common factor. It's numerical. And then we look at our denominators to find the least common denominator. We've got a 3, a 4, and a 2. Well, 3, 4, and 2. The smallest number that 3, 4, and 2 all have in common is 12. Then I have an n plus 1, an n minus 1, and an n plus 1. That means that I need an n plus 1 and an n minus 1 in my least common denominator. Okay, give me another moment. Augie's playing with my cord again. Here, buddy. Okay, go play. All right, you go play for me? All right, sorry about all these interruptions. Okay, so our least common denominator is going to end up being 12, n plus 1, n minus 1. So again, if you can ignore the pink, it's a little distracting, I guess. Actually, you know what? I'll just rewrite it out for you on a different sheet of paper. Let me grab my notebook. Okay, so we have 7n over 3 times n plus 1. Buddy, let go, please. I'm so sorry. Okay. Here we go. And then we have minus 5 over 4 times n minus 1 equals 3n over 2 times n plus 1. Okay, so there's where we are as far as the factoring piece. We said the least common denominator will be a 12 because 3, 4, and 2 all have 12 in common for the least value. And we have an n plus 1 and an n minus 1. Okay, so what we're going to do is we're going to take that 7n over 3 times n plus 1, and we're going to include our least common denominator in the numerator. Minus 5 over 4 times n minus 1. And again, we're going to multiply that. We're going to multiply everything by the least common denominator, which always goes up into the numerator. Okay, there we go. Now I have everything written factored and with the least common denominator multiplying to every single term. Now I want to cancel out what I can. So I'm noticing that 3 goes into 12 4 times. That's going to leave me with a 28. I also have an n plus 1 on both the numerator and the denominator. So I'm left with a 28n times n minus 1. Here, I notice 4 can go into 12 3 times, so 5 times 3 is 15. My n minus 1s cancel out, and I'm left with n plus 1. And then on the right-hand side, 2 goes into 12 6 times. 3 times 6 is 18. My n plus 1s cancel out. I'm left with an n and an n minus 1. Okay, so that's what happened in this step of pink and to this step here. All right, now we distribute. So take that 28n to both those terms, the negative 15 to both these terms, and the 18n as well. So there's our distributive property for each piece. Don't forget to take your negatives with any of those terms. I combined like terms, 28n squared, and then I subtracted 18n squared to get 10n squared. Here I took negative 28n minus 15n, and then I added 18n to get terms on the same side. And then negative 15 stayed there. So basically in one step, I combined like terms and rewrote it in standard form. So I have a quadratic here. So now we're going to solve either factoring or quadratic formula, which I didn't take the time to write out, and I don't want to waste more video time doing that. So that's from chapter 4 and 5 if you need to review that. And these are the two solutions we get. We want to check to make sure they're extraneous or not, which I told you they wouldn't be. But if we go up here, the only values that would give us extraneous are 1 and negative 1 again, because that's what would give you 0 in any of these denominators. So both these answers are actually applicable here. Okay. And then we have one more to do. This is 2D. Okay, so same approach we just did. Here we have p minus 2. Oh, we have a trinomial and then a p plus 4. So none of these can be combined by creating a proportion. So all we can do here is factor. And all we can factor is this denominator here. Factors of -8 that add to 2 would be a +4 and a -2. And again, I'm going to rewrite this step here that's in pink just so it helps carry it out a little bit easier for you instead of just looking at it and trying to make sense of it. So our least common denominator, I have a p minus 2, I have a p plus 4. That's all I'm seeing, so that's my denominator, my least common denominator. So that's what I'm going to take to every term. I have a 1 over p minus 2, and I'm going to multiply that by my least common denominator. I had a, let's see, I had a equals 2p plus 1 over p plus 4 p minus 2, and I'm going to multiply that by my least common. Oh, did I lose you? My phone kind of froze. I'm going to say that again. So I had 2p plus 1 over p plus 4 p minus 2, and I'm going to multiply that by the least common denominator, p plus 4 p minus 2. And then my last term was a plus 2 over p plus 4, and I'm going to multiply that by my least common denominator. Okay, so now I have the same equation, 3 fractions, and I multiplied all of them by my least common denominator. Cross off what we have in common. This one ends up being less work than example 2C. I'm just left with the p plus 4 on the top for the first fraction. I'm just left with a 2p plus 1 in the second fraction, and I can keep these in parentheses, but since there's no distributing happening with the number out front, they're not necessary. Plus, and then I can cross off p plus 4s. This one I would have to have my parentheses since I have that 2 out front to distribute. And now I simplify and solve. Okay, so distribute, combine like terms, 2p and 2p, 1 minus 4. This one's nice, it's not going to end up with quadratics, so this is even less work than the last example. Subtract 4p to the left, subtract 4 to the right. We get a fraction of 7/3. Go back up here to make sure this works, and it does. The only restrictions I would have in this problem are a +2 and a -4, so 7/3 is my answer. And that wraps up day 1 of 8-6. If you have any other questions, don't forget about Connect Ed or send me an email.